Oh, no. All right. An exponential function. Ready? Okay. So you need to know the apparent function, the general form of an exponential function. You've probably seen them before at some point, maybe in science or in, I don't know. I don't know if you do it in geometry or not, but did you? In freshman geometry? Okay. So it has this form. A is not 0. What would happen if A was 0? It would just be y equals 0, right? Okay, that wouldn't be an exponential function. And b has to be greater than 0, not negative. Okay, so that's the two requirements. A growth function is when b is 1. B has to be 1, or no, excuse me. Yeah, greater than 1, 1 or greater, 1 or greater. Let's be greater than 1. God, I can talk. I had coffee this morning, and I haven't drank coffee in forever, so I'm like, woo! I was very productive on my planning, but I'm a little wired. All right, and the curve goes up and to the right, and you'll see all this. The growth factor is b. It's what the function is being multiplied by repeatedly. That's the growth factor, and you'll see that as we go on. Asymptote, we've seen that word before. In what? Remember asymptotes? Conic sections, right? We saw that in conic sections. Okay, so we get to repeat that again a little bit. We're going to see those again. All right, so the parent function, it's written like this. It's when a is just 1, so there's no a in here. That's the actual most basic function. For a growth, exponential growth, b has to be greater than 1. Must be greater than 1 for exponential growth. The general shape of the graph is, and we're going to take a look at that right now. So the graph rises from left to right, passing through the points 0, 1, and 1b. So I just want you to put 2 points here, and I'm going to show you this. And what happens is, in the parent function, the x-axis is your asymptote. And we saw before with asymptotes that the functions do what? They get closer and closer to it, but they never cross over it. So it's kind of like this. This is a general exponential growth function. Never goes below the x-axis. Do not do that in your sketches. Do not do it on your quiz. Do not do it on your test, because if you go below the asymptote or cross it, I will mark it down. Just a little bit picky about that. So let's just pick a function just to see what's going on here. Y equals 2 to the x. Okay? Is b greater than 1 here? Yeah, this is my b, right? It's greater than 1. Okay, so I'm going to make a little table and just kind of show you what's happening. I am going to put -2 here for x. We won't look at that quite yet, but I'm going to put 0, 1, and maybe 3, just to see why it climbs so rapidly. If I plug in 0 for x here, what do I get? 2 to the 0 is 1, isn't it? That's where this point comes from, 0, 1. Make sense? Okay. If I put in 1 for x, what do I get? 2. That's where this point comes from, the 1b. See, b is 2, right? b is 2, so it's over 1 up 2. That's where that point comes from. All right? Now, if I put 3 in, what happens? This jumps to what number? 8. So it jumps quickly, because I'm multiplying by 2 every single time, which causes that exponential growth. It jumps very quickly. Okay? Now, you may wonder, or you may not, and I'm going to tell you anyway, where this comes from. Why is it like, so small and then it climbs so big? Well, you know this. You know negative exponents. If you stick -2 in for the exponent, what does that number actually mean? It means 1 over 2 squared, which is what? 1/4. So if you have an exponent of a negative number, it's actually a very small output there, 1/4. And that's why this is smaller and smaller and smaller and smaller. And it will just keep getting smaller and smaller and smaller and smaller, but never go below 0. So that's where this all kind of comes from. Make sense? All right. The domain of y equals b to the x, or exponential growth, is reals. It will always be all reals for exponential functions. X can be absolutely anything in an exponential function because the graph goes forever. However, looking at your function here, the y values are always going to be what on this particular function? Are they ever going to be below 0? Are they ever going to be 0? For this function right here? No. So for here, the range is all reals, but greater than 0. Not greater than or equal to, because they're never going to be 0. Yeah? Okay, that's the parent function. Now we get to shift it. Yes, Ben?
What about the space?
The space where? Here?
No.
You mean here?
No. Up. You left out the space.
Oh, this empty space. Oh, with a base B. Sorry. Okay. Graph this function. All right. Y equals 1/4 times 6 to the x. What is the 1/4? That's your A, which is causing a what? A shrink or a stretch, right? Is this causing a shrink or is this causing a stretch? A shrink, because it's between 0 and 1. So A is, 1/4 is A, which will cause a shrink. It is not B. Because B is 6, you have to be able to identify that that's going to be an exponential growth, because B is greater than 1, right? So first we plot 0 and 1/4. Where did I get that from? Yeah, if I plug in 0 for x, this becomes 1 times 1/4, correct? And then 1, so 6 to the 1 is 6. 6 times 1/4, does anybody know what that is? It is 1.5. 6 over 4 would reduce to 1.5. Then from left to right, draw a curve that begins just above the x-axis, passes through the 2 points, and moves up and right. So let's plot these 2 points. 0, 1/4, you just kind of guesstimate where that would be, about 1/4 up the y-axis there. Over 1, up 1.5, so there's my 2 points that I know I can graph. And then I just kind of sketch, but I never ever go below what? Really close. So there's a little bit of a shrink here, just a little bit of a shrink. That's that. Doable? Turn the page. Now we get to shift it more. Okay, we have H and K now. We had A, now we have H and K added in. What does the H do? Horizontal shifting, correct? Translating. What does the K do? Up and down. Okay? H is part of the exponent here because it's affecting the X. And then this is just on the outside like it always is. So, we're going to graph this right here. This is my H, this is my K. And then we're going to state the domain and the range. So let's think about the basic function. When we first graph the basic function, we're not going to consider any of this H and K stuff. We're just going to consider the y equals A times B to the X. So I'm going to say y equals 2 times 3 to the X. That's my basic function right there. Just in case you've forgotten, it's this. All right, the basic points here. If I plug in 0, what is my output going to be? 2. If I plug in 1, what's my output going to be? 6. So those are my basic points. I'm not going to plot them right now. Okay, now the translation that I have to do, what does the H cause it to do? Left or right?
Right.
It's right, because we started with a minus, so that means that H has to be positive in there, right? So the translation means I'm going to go right 2. And then this is a minus 2, which means I'm going to do what? Down 2. So then I'm going to consider these two things and change my 2 points accordingly. Okay, so if I go right 2, for my x coordinate, it's going to change to what? 2. I'm going to add 2. If I go down 2, my y coordinate is going to become what? 0. Do the same thing for this point. If you go right 2, the x is going to be 1 plus 2, which is 3. And then that's going to go down 2, which is 4. Put down 2 there. All right, the asymptote is going to be y equals negative 2. Does anybody know where I got that from? Anybody can see it from the equation? What do you think? It's not the h. It's the k. It's the y. It's the y. And you'll see it once we graph it. It's based on the k value. Asymptote is always going to be based on the k value. What's the domain for any exponential function? All reals. And then let's graph it and see what happens, and then we'll answer the range. You really don't need to. You can answer the range before that. But first thing I always like to do is draw my asymptote. So y equals negative 2 is right here. That's my asymptote. I know I'm never going to go over that line. Then I'm going to plot these 2 points, the new points. Over 2, up 0. Over 3, up 4. It's exponential growth, so it's going to go up from left to right. And it's going to just come really, really, really close to my asymptote, but not go below it. And then just kind of curve up like that. Sort of a sketch. You really only need those 2 points and the asymptote. Okay, my range, you can kind of see it. It's going to be greater than or equal to what? What's this value right here? Negative 2. Pardon me? Not equal to, right? Just check and see if you're awake. Greater than negative 2. All right, that's that one. Let's just do one more, and then we'll be done with 7. No, am I lying? No. Oh, no, we got more in 7-1. There's more fun stuff. Okay, this will be quicker. The basic function is y equals 2 times 4 to the x. So I'm going to get my 2 basic points using 0 and 1. If I plug in 0, what is my output going to be with the basic function? 2. If I plug in 0. If I plug in 1, what's my output going to be? 8. Okay. Here is my h. Here is my k. I'm going to be translating horizontally how much? Left 1, right? And then what? Down 3. So you change your points to reflect that. Left 1 means you're subtracting 1 from your x. Come on. So your new points are going to be negative 1 and negative 1. And 0 and 5. For the first one, 2 minus 3. So we're subtracting 3 because we're going down 3. Okay? Okay. And then the asymptote is going to be what? Y equals what? Negative 3. The domain is going to be what? All reals. And your range is going to be based on this right here. What? Yep. All reals greater than negative 3. So sketch your asymptote. Sketch your new points. Negative 1, negative 1. Now some of you are seeing that maybe you can shift without all this work. That's fine. If you can visualize that, go ahead. I don't care. Over 0, up 5. 1, 2, 3, 4, 5. So it looks something like this. Sketching is important, but application is more important. When will you use this? Let's talk money, shall we? All right. This is how you can apply exponential functions to money. You will need to know this. Eventually, you'll need to know that equation. It's a very common equation you'll use if you go into business math, pre-calc, whatever. This here tells you what all of the variables mean. Y is the final amount, the money you'll make or lose. Actually, this is make only. A is the initial amount you start with. Let's say your rich uncle gives you $2,000. That's your A. That's your starting amount if you put it in an account and start to earn interest, okay? R is your growth rate, but you're always going to write it as a decimal. And T is the amount of time, usually in years. And N is compound in years. Okay? All right. Now, this, you may need this table eventually. If you're not sure what compounded bi-monthly means, that means 6 times a year. I just put this in here for reference. Compounded weekly, there's 52 weeks in a year. Okay? Because N represents the number of compounds in a year. So I just put this in here for your reference if you need it, maybe while you're practicing on Monday. Let's do some of these. While observing buffalo for 12 years, the rangers realized that an initial population of 38 buffalo in a state park grew by 7% per year. Okay, so first of all, if I'm working with this equation, I know this is my initial, my A, right? And they put that percentage in there. It grew by 7% per year. This is my R, and I'm going to write it as 0.07. The 12 really has nothing to do with the equation. It's just saying they observed for 12 years. Okay, and I'll show you why. It says write an equation using the above information. When you see this, you're not doing any solving. You're not coming up with any final number. You're writing a general equation that they can plug in any year for T and find out how many buffalo. So we're going to write this. Y equals, what's my starting amount? 38. Okay. Then I'm going to do the 1. That's part of my equation. What's my rate? Yes. And what is my N? What did we decide? Since it's per year, N is just 1, right? N is just 1. So we really don't need to worry about N. So it's going to be 1 plus 0.07. And I want to keep this as a general equation where I can stick any time in there. So I'm just going to use T. That's my answer for that. Write an equation. Okay? N, again, is 1. So we don't need to worry about N here because it's per year. Make sense? Okay. Then it says for part B, estimate the number of buffalo in the park after 7 years. Well, what do I do with that 7? Plug it in for T. That's my T. So Y equals 38, and I would actually write it like this, to the 7th. This is the same as this. Hopefully you see that. That's the same as that. Yeah? Okay, and then when you do that, you get 61 buffalo. Eventually, you're going to be given equations where you need to recognize whether that exponential equation is growth or decay. So you look inside here, that's called your growth factor. If it is greater than 1, that's your B, isn't it? If it's greater than 1, it means it's doing what? It's growing. Okay. You deposit $2,900 in account that pays 3.5% annual interest. Annual means once a year. So right here, this is my A, this is my R. It's going to be written as what? Nope. This is tricky. People screw up on this all the time. Changing 3.5 to a decimal would be what? 0.035. Be careful. You move it 2 places to the left. 0.035. Okay? Find the balance after 1 year if the interest is compounded annually. You could write up here annually is the same as yearly. Did I spell that right? I don't even know. Annually is the same as yearly. So once a year. So what's my n going to be? 1. Okay? So let's write this equation. Y equals my starting amount times 1 plus my rate. And I'm only going to see how much it is for 1 year. So just for the heck of it, I'm going to write it like this because I want you to see that. These are the same. Sometimes that confuses people. When you do that math on your calculator, you just do one quick swoop and you get 3,000. How much money did they make? They went from 2,900 to 3,000, so they made what? 100 and 150, right? Okay, that's a pretty good interest there. All right, if the interest is compounded monthly, oh, wait a minute, if it's compounded monthly, what's my n going to be? N equals 12 here. So let's write this equation now using n. So I have my starting amount, 1 plus my rate, which is still 0.035, but now I have to divide it by n, which is 12. And then the other part of the equation is 12 times t, right? So n is 12, and my t is still 1 year. After 1 year, okay? And when you're doing this on the calculator, just make sure you're using parentheses in the right spot. If it were me, I would do this piece first, and then I would multiply by 2,100 or 2,900, and then I'd raise it to the 12th. Just be careful when you're doing that. That equals 3,314. Are you making that much more money? Compounded monthly? Not really, right? Just a little bit more, not much. All right, I want you to try this one. You deposit 5,000 and that pays this. Find the balance after 3 years. So this is your A, this is your interest, this is your T, compounded quarterly. That tells me my N is what? 4. N is 4. Okay, so try and find out how much money you'll have. This is what you should have gotten. See how it went. No, yes, maybe? Check it out, see what happened.